So here we are going to talk about copy constructors in C++. So we will see what are copy constructors, and then we will look at deep and shallow copies. So these are some of the favorite topics of interviewers. Okay, so you should be very clear about them. So let's see the copy constructors. So these are used when you want to make a copy of an existing C++ object. Okay, so I want to make a copy. How will I do? So it's something like int a is equal to something like a is equal to b, what we do, so that it is copied the contents of b into a. But here in case of class, so it's much more difficult because each class has a lot of attributes. Okay, so all of them needs to be copied. And what happens? So the signature basically looks something like this: my class const my class ampersand other, my class, then my class ampersand others. So these are the two signatures. So this is a constructor, a copy constructor is a constructor. Then it says what we need to copy. So I will copy an object which is of the type that class itself. So I will pass a reference to my class itself, and I can make it a const so that it cannot change the object from which I am copying. Or otherwise, even if I don't make it a const, it will work fine. Okay, so this is the case, and what happens is that even if you don't write a copy constructor, C++ writes for you a default copy constructor. So let's see with an example. Class, my class, int a, double b, and standard string c. So I have three attributes in my class: an integer a, double b, and a standard C++ string c. Okay, so if I don't make a constructor here, copy constructor, so the default copy constructor would be something like this, written by the compiler: my class const my class ampersand other. It will make a is equal to other dot a, b is equal to other dot b, and c is equal to other dot c. So this is what it does, and this is the simple compiler, the compiler copy constructor. Okay, so it basically makes a shallow copy of these variables. So other is, so if it is something like, if I make something like my class a, okay, and let's say we had made them public, okay, just for easiness. So now I do a dot a, okay, so is equal to 5, a dot b is equal to 7.5, and a dot c is equal to hello. Okay, so now what happens is, so this is created, it all has memories and all. Now when I do my class b, okay, and my class b, and let's say b a, something like this, or my class b is equal to a. So this will call a copy constructor. A will be passed as an argument, and everything like b dot a will become a dot a, b dot b will become a dot b, and b dot c will become a dot c. Okay, so everything will be assigned. But what happens is C++ classes have a lot of raw pointers. Okay, so this was shallow copy constructor, so we just assign all the variables as equal, even the pointers. Most classes in C++ have raw pointers. Okay, so they are pointing to, we have pointers which point to some objects and memory location. So what we do is, we should not copy the pointers. Okay, that okay, this pointer I make it equal to other pointer, so that two pointers are pointing to the same object. Okay, so this is not good. Why? Because let's say if one of the object goes out of scope, or its destructor is called somehow, it will delete this pointer, so this memory location will become free, and now this other pointers which I have copied from there will be pointing to something out of scope. So this is dangling now. Okay, so if one class destructor is called, it will corrupt other classes object, because they will not have that pointer pointing to something valid. Okay, so this is the problem. So we use something called deep copy. So where what we do is that instead of just pointing these pointers to that memory location, I make a copy of that whatever content was there and point this one here. Okay, and the third one also I will copy and point to the third memory location, so that even when a destructor is called, so this is gone but its copy is still intact in the second object's pointer, okay, and the third object. So we will take it with an example. I define class myArray, and it has what I am making an array class, and I give it a size and I give it a pointer which points to something. Okay, so the array. Okay, and explicit myArray constructor is int s. I give it the size becomes s, and data becomes new int s. So I allocate memory to it and delete. So in the destructor I call delete this data. Okay, so this is very simple myArray class, but let's see is the simple. I don't define here a copy constructor. Okay, so I have not given a copy constructor. So what happens is, again, so it will make a default copy constructor, the compiler, and it will write something like myArray. Okay, so myArray, and here it will have const my class ampersand other. Okay, so this will be there, and then what happens is, now we will have something like size will be other dot s, and the data will be equal to other dot data. So this is the default constructor, copy constructor, and what will happen is that size will be copied, but data, let's say if the first copy was pointing to, let's say, 20 elements, so these 20 elements, if I make a copy, so that will also point to the second object's pointer, will also point to the same memory location. Okay, so this is the case for default copy constructor. So let's see. So now in int main, what I do is myArray first I give it, so 20 size is it, and I say that first dot data 0 is 25. Okay, so now the first object is created and its data is now pointing to 20 memory locations. Okay, and first one I say that it is 20 here. Okay, now what I do, so it's 25 data 0 of the first object. Now in this braces, so I make myArray C first, copy of first is equal to first. So now what happens, this in turn calls what, so C first copy constructor will be called. Okay, and so first will be passed as an argument. Okay, so it comes here, and I have size becomes other dot size, so size becomes 20, and data becomes equal to other dot data. So this makes it point other dot data. So C first dot data is also now pointing here, and this is first dot data. Okay, so now what happens, both of them have this pointing to the same memory location. Now I do C out first dot data 0, it prints out 20 very well, so the 25, then C first data 0, so 25. This is perfectly fine. Okay, but then I come out here, braces scope goes away, and this was a variable, local variable, automatic variable here. So this is automatic variable and it goes out of scope. Okay, out of scope, it goes away, and what we see here is, so first dot data 0, now again I try to access, but now it gives me a segmentation fault. Okay, so I get a segmentation fault, and why so? Because now this is freed, the destructor will be called here. So destructor of C first is called, it deletes this array, and this memory location is freed, but now also first dot data is pointing here, and when I try to access first data 0, it gives me a segmentation fault. Hence what we should do is we should write our own deep copy constructor. So I should write my array, const my array ampersand other, size is other dot size, this is fine, but data I allocate a new int other dot size, so I allocate a new memory. Okay, so this was the first one. Now I say that okay, I am also allocating a memory size equal to this, and then I copy the different content here. Okay, so I use standard copy other dot data plus other dot size from here to here. I copy this thing in this new data. Okay, so this pointer, so this helps me now. So now what happens, even if this is gone, so now it had a different copy here, so that will be deleted and not this one. Okay, so this will not give us a segmentation fault. So this was about copy constructor, about shallow copy and deep copy constructors. Hope you understand this and like this video. If you like this video, please subscribe to my YouTube channel and share it among your friends.